بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Good morning, my dear students, and welcome to this lecture related to Chapter 2 entitled Virtualization. So, before starting this lecture, you are expected to be able to first define the concept of virtualization and its importance. Two, distinguish between the different virtualization areas. Three, explain the criticality and performance of virtualization. Four, discuss the different types of virtualization. Five, determine the well-used and known solutions related to virtualization. And finally, explain some or the main advantages and disadvantages of virtualizing. So the main topics of this lecture, at first we will explain what is the virtualization concept. After that, we will talk about some virtualization area, also the criticality and performance of virtualization. Also, I will provide you some solutions related to virtualization and its cause. And finally, we will highlight some advantage and disadvantage of using virtualization. So, what is virtualization? Virtualization is a technology that you can use to create virtual representations of servers, storage, networks, and other physical machines. Virtual software mimics the functions of physical hardware to run multiple virtual machines simultaneously, to use their hardware resources efficiently and get greater returns from their investment. It also powers cloud computing services that help organizations managing their infrastructure more efficiently. Now, why is virtualization important? By using virtualization, you can interact with any hardware resource with greater flexibility. Physical servers consume electricity, take up storage space, and need maintenance. So you are often limited by physical proximity and network design if you want to access them. Virtualization removes these limitations by abstracting physical hardware functionality into software. So you can manage, you can maintain, and you can use your hardware infrastructure like an application on the web. Let's now highlight some or a concrete virtualization example. Consider a company or an organization that needs servers for three main functions. The first function is to store a business email securely. The second function is to run a customer-facing application. And the last function is to run internal business application. So each of these functions has different configuration requirements. The email application requires more storage capacity and a Windows operating system. The customer-facing application requires a Linux operating system and high processing power to handle large volumes of website traffic. The internal business applications requires iOS and more internal memory, RAM. So to meet this requirement, the company sets up 3 different dedicated physical servers for each application. The company must take high initial investment and perform ongoing maintenance and upgrades for one machine at a time. The organization also cannot optimize its computing capacity. It pays 100% of the server's maintenance costs, but unfortunately uses only a fraction of their storage and processing capacities. Since we are talking about virtualization, it's essential to talk also about the main topics related to virtualization, which are virtual machines and hypervisors. What is a virtual machine? Virtual machine is a software-defined computer that runs on a physical computer with a separate operating system and computing resources. The physical computer is called the host machine, and virtual machines are called guest machines. Multiple virtual machines can run on a single physical machine. Virtual machines are abstracted from the computer hardware by a hypervisor. Now, what is a hypervisor? The hypervisor is a software component that manages multiple virtual machines in a computer. It ensures that each virtual machine gets the allocated resources and does not interfere with the operation of other virtual machines. Now, what are the main benefits of using virtualization? In fact, virtualization provides several benefits to any organization, and which can be summarized in 3 main benefits. The first one is about efficient resource use. The second one is about automated IT management. And the last one is about the faster disaster recovery. What we mean by the efficient resource use. In fact, virtualization improves hardware resources used in your data center. For example, instead of running one server on one computer system, you can create a virtual server pool on the same computer system by using and returning servers to the pool as required. So having fewer underlying physical servers frees up space in your data center and saves money on, for example, electricity, generators, and cooling appliances. The second benefit refers to automated IT management. Now that physical computers are virtual, you can manage them by using software tools. Administrators create deployment and configuration programs to define virtual machine templates. You can duplicate your infrastructure repeatedly and consistently and avoid error-prone manual configurations. The last benefit refers to faster disaster recovery. So when events such as natural disasters or cyber attacks negatively affect business operations, regaining access to IT infrastructure and replacing or fixing a physical server can take hours or even days. By contrast, the process takes minutes with virtualized environment. This prompt response significantly improves resiliency and facilitates business continuity so that operations can continue as scheduled. Now let's talk about the concept of consolidation. Before talking about consolidation, it's important to know what is the main reason to consolidate server. In fact, with the use of the traditional manner of processing data, computers were only able to run one process at a time. So, which means that the computational complexity will be increased. So, to solve this problem, it's important to use consolidation or server consolidation. In fact, server consolidation in cloud computing refers to the process of combining multiple servers into a single, more powerful server or cluster of servers. This can be done in order to improve the efficiency and cost effectiveness of the cloud computing environment. Server consolidation is typically achieved through the use of virtualization technology, which allows multiple virtual servers to run on a single physical server. This allows for better use of resources as well as improving scalability and flexibility. It also allows organizations to reduce the number of physical servers they need to maintain, which can lead to cost savings on hardware, power, and cooling. Now, we learned what is the concept of consolidation. Now it's important to explain or to discuss about its architecture. As shown in this graphical representation of server consolidation, multiple physical servers are consolidated into a fewer number of powerful servers using virtualization. Okay, this process results in the creation of logical servers which are isolated from one another and have their own operating system and application, but share the same physical resources such as CPU, which is the central processing unit, RAM, and storage. So, physical servers, virtualization software, and virtual servers make up the three primary parts of the server consolidation architecture. Let's explain the first part, which is the physical servers. The server consolidation environment's hardware consists of physical servers. So these servers are usually powerful machines with high processing speeds that are built to manage massive volumes of data. They are used to run virtual servers and host virtualization software. The second part, which refers to virtualization, and as explained previously, a single physical server can run several virtual servers thanks to virtualization software. So multiple virtual servers can share the resources of a single physical server thanks to software creation of an abstraction layer between the real hardware and virtual servers. The last part, which is about the virtual servers. So physical servers are virtualized into virtual servers. They run on top of the physical servers and are produced and controlled by the virtualization software. Each virtual server can execute its own programs and services and is a separate instance of an operating system. So, server consolidation creates, in fact, virtual servers that share the resources of the physical servers by fusing a number of physical servers into a single virtualized environment using virtualization software. This makes it possible to use resources more effectively and save money. Additionally, it makes it simple to manage existing servers, set up new ones, and scale resources up or down as necessary. Now, it's important to ask an important question. How is virtualization different from cloud computing? Cloud computing is the on-demand delivery of computing resources over the internet with pay-as-you-go pricing. So instead of buying or owning and maintaining a physical data center, you can access technology services such as computing power, storage, and databases as you need them from a cloud provider. For virtualization technology, which makes cloud computing possible. So, cloud providers set up and maintain their own data centers. They create different virtual environments that use the underlying hardware resource. You can then program your system to access these cloud resources by using API. So your infrastructure needs can be met as a fully managed service. Now let's talk about the different type of virtualization. You can use virtualization technology to get the functions of many different types of physical infrastructure and all the benefits of a virtualized environment. You can go beyond virtual machines to create a collection of virtual resources in your virtual environment. Let's start by the first type, which is the server virtualization. Server virtualization is a process that partitions a physical server into multiple virtual servers. It is an efficient and cost-effective way to use server resources and deploy IT services in an organization. Without server virtualization, physical servers use only a small amount of their processing capacities, which leave device idle. The second type, or before talking about the second type, here it's important to talk in details about the main concepts related to server virtualization, which are the hypervisor. As defined previously, hypervisor is a type of software or hardware used to create virtual machines and then run those virtual machines day to day. You will sometimes see the same technology referred to as a virtual machine monitor, known as the VMM, which is a reasonable encapsulation of what a hypervisor does. A hypervisor might be hardware, or it could be a program to manage virtual machines, whether software or firmware. What makes a hypervisor is what it's used for: create, monitor, and manage virtual machines. In fact, there are two types of hypervisor, each differing in architecture and performance. The first type is type 1 hypervisor. The type 1 hypervisor sits on top of the middle servers and has direct access to the hardware resource. Because of this, the type 1 hypervisor is also known as a bare metal hypervisor. The host machine does not have an operating system installed in a bare metal hypervisor setup. Instead, the hypervisor software acts as a lightweight operating system. Now, let's explain some or the main pros and cons of using type 1 hypervisor. Due to its architecture, the type 1 hypervisor is very efficient. It can directly manage and allocate resources for multiple virtual machines without going through the host operating system. So these types of hypervisors are also more secure, as the absence of a host operating system reduces the risk of instability. The second type of hypervisors is type 2. The type 2 hypervisor is a hypervisor program installed on a host operating system. It is also known as a hosted or embedded hypervisor. Like other software applications, hosted hypervisors do not have complete control of the computer resources. Instead, the system administrator allocates the resources for the hosted hypervisor, which it distributes to the virtual machines. In fact, the presence of the host operating system introduces latency to the virtualized environment. When the virtual machines request computing resources, the hypervisor cannot directly access the underlying hardware, but relays the request to the host operating system. Also, the hypervisor and its hosted virtual machines are dependent on the stability of the host operating system. Now, let's compare between these two types, type 1 hypervisor and type 2 hypervisor. Despite their differences, both types of hypervisors are helpful in different applications. For example, enterprise-cooled or enterprise cloud data centers use type 1 or bare metal hypervisor because of their efficiency, scalability, and flexibility when allocating resources to virtual machines. Also, a type 1 hypervisor is generally more secure and stable because it does not run on top of another operating system. Conversely, administrators use type 2 hypervisors because they are more user-friendly. Type 2 hypervisors are easier to install, to configure, and use than bare metal hypervisors. It is similar to installing and using other desktop applications. Now let's move to the second type of virtualization, which is the storage virtualization. Storage virtualization combines the functions of physical storage devices such as network attached storage, known as the NAS and AS, and the storage area network, known as SAN, S-A-N. So you can put the storage hardware in your data center, even if it is from different vendors or of different types. So storage virtualization uses all your physical data storage and creates a large unit of virtual storage that you can assign and control by using management software. IT administrators can streamline storage activities such as archiving, backup, and recovery because they can combine multiple network storage devices virtually into a single storage device. Now let's explain the third type, which is the network virtualization. Any computer network has hardware elements such as switch, routers, and firewalls. An organization with offices in multiple geographic locations can have several different network technologies working together to create its enterprise network. So, network virtualization is a process that combines all of these network resources to centralize administrative tasks. So here, administrators can adjust and control these elements virtually without touching the physical components, which greatly simplifies network management. In fact, for this type of virtualization, it's mainly based on two approaches: the software-defined networking and the network function virtualization. What we mean by software-defined networking? Software-defined networking, called also the SDN, controls traffic routing by taking over routing management from data routing in the physical environment. For example, you can program your system to prioritize your video call traffic over application traffic to ensure consistent call quality in all online meetings. The second approach, which is the network function virtualization. Network function virtualization technology combines the functions of network appliances such as firewalls, load balancers, and traffic analyzers that work together to improve network performance. Now, we talked about virtualization, its different types. We talked about consolidations. Now, why we virtualize? So, in fact, virtualization or its benefits, it's mainly related to three main points: cost, criticality and performance, and security. When we talk about cost or reducing expenses, in fact, computing power comes at a price. If the only way to get more resources is to purchase a new hardware, that price becomes hefty. So, with virtualization tactics, you can take a hard look at your existing infrastructure and identify wasted or idle computing resources. Too often, organizations deploy servers to run applications that consume only a fraction of their available resources. Such servers never make use of their full potential. So, to make matters worse, when their applications are not running, the servers sit entirely idle. In a virtualized environment, you can assign each virtual machine precisely the amount of computing power it needs to do its job. The remaining resources are then available for other virtual machines and their applications. So, virtualization costs are almost always lower than the cost of purchasing and maintaining additional hardware. The second benefit is the resiliency. A virtualized server environment is not bound to hardware like a traditional environment. So you can easily back up, copy, and clone virtual machines to different physical hardware. Waiting for new hardware to be ready for deployment can take days, weeks, or even months. Meanwhile, you can deploy a virtual machine backup in a matter of minutes. When Murphy's Law finally catch up with you, you will be thankful you can rapidly deploy your virtual machine on a different machine in a different location with minimal hassle. The third benefit is about high availability. Since you can clone a virtual machine almost effortlessly, you can easily set up redundant virtualized environments with exceptionally high availability. By automatically monitoring virtual machine status and rapidly switching to backup virtual machines in a now stage, virtualization provides an extremely reliable system with no single point of failure in hardware or software. So this failover system enable you to seamlessly continue operating with virtual machine from its last working state. So this maximizes service availability no matter what goes wrong. You can remotely monitor, configure, and restart your entire virtual environment. This provides developers constant access no matter how far they may be from the physical hardware, which helps further mitigate any potential downtime. The benefit number 4 is about increasing efficiency. Virtual environments are much easier to maintain than physical environments. Rather than managing numerous physical servers requiring individual attention, virtualization enables you to configure, monitor, and update all your virtual machines from a single machine. This saves time deploying updates, implementing security patches, and installing new software. So with less physical hardware to worry about, your IT department spends less time maintaining physical machines. And your developers enjoy the efficiency of rapidly spinning up a virtual machine without having to worry about adding new hardware. By nature, virtual environments are inherently scalable. You can easily deploy many instances of the same virtual machine to help handle heavy load, offering efficient scalability that is always ready to support and sustain growth. The fifth benefit is about developing or making development easy. Virtualization is a developer best friend. It effectively segments production and development environment without extra hardware. It is simple to clone a virtual machine to set up testing environment. You can test features and squash bugs without affecting your live product. So, with traditional hardware-based environments, developers need to manage all the updates and maintenance for their development machines. So, maintaining an accurate representation of live servers for testing is also an ongoing challenge. Virtual machines quickly solve all these issues. Virtualization provides on-demand access to an infinite number of perfectly replicated virtual machines for developers to play with. So here, developers take advantage of virtualization to help them expedite updates, improve software security, and maintain an efficient pipeline between development, testing, and deployment. The last benefit is about or refers to a greener IT. In the long run, virtualization is an eco-friendly approach to IT, reducing hardware requirements also reduces power consumption, ultimately minimizing our carbon footprint. This is good for both the environment and your bottom line. Power savings make it cheaper to maintain servers and data centers. So you can then invest all that money in other ventures, like making your business even more environmentally friendly. Now, let's talk also about some points reduced to cost, and which can be also summarized as explained previously in 8 main points. Reducing number of servers, reducing network hardware, reducing power consumption, reducing air conditioning requirements, reducing space consumption, aggregating idle loads, optimizing restoration, and optimizing backup. For the criticality and performance is summarized in 6 main points, which are about simplicity of deployment, simplicity of administration, improving change management, optimizing physical capacity evolution, improving load balancing, and the simplicity of software testing. Okay, now let's jump to one of the most important and essential aspect related to virtualization, which is security. As explained, virtualization will allow isolation of different software environments at the physical resource level. So communication between different virtual machines will only be possible via network connection in the same way as communication between two physical machines. Here, we will focus on the problem of or addressing the problems of security in virtualization. Virtualization centralizes administrative tasks while improving scalability and workload, and leads to the consolidation of network infrastructure, lower OpEx, and ease of management. However, virtualization also introduces security challenges that physical security system cannot adequately protect against. And here we have some examples of these challenges. The first one is about file sharing between host and guest, which is not secure. The second challenge is about the isolation between components such as guest operating systems and applications, hypervisors, hardware, and awakening. The third challenge is that multiple servers are consolidated, which increases the risk that a compromise may spread from applications on the same host. The last challenge is that for the intrusion prevention systems known as IPS, malware targeted for physical and virtual machines causes infection via the virtual network. Other security threats include, for example, unauthorized access, denial of service, and exploits. So many organizations do not realize that using their existing legacy security solutions can expose them to these types of attacks and data loss. So what can you do with security virtualization? Security virtualization acts as a barrier to secure perimeter access to a network. It provides dedicated security services and assures traffic isolation within the cloud, along with customizable firewall controls as an additional managed service. So enterprises and service providers can leverage their virtualization investment to create a granular security perimeter, giving dedicated security resources within a cloud construct to tenants and service subscribers. So this is what we have for this lecture, which is the first part of chapter 2. Inshallah, in the next recorded version, we will talk about the full or the main or the different type of virtualization, which are full virtualization, para-virtualization, hardware-assisted virtualization, and partitioning. We will also talk about some existing and well-known solutions, such as Xen, KVM, VMware, and Hyper-V, which will be also explained in details. And also, we will have the opportunity to explain or to show the main advantage and disadvantage of using virtualization. So this is what we have for this lecture. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.